Chapter 17 worksheet, chi-square explanation. All right, so chi-square is used mostly with categorical data. We'll go over question 1 step by step on how to solve a chi-square problem. So, in the United States, 62% of dog owners own only one dog. 26% own two, 7% own three, and 5% own four or more. All right, that is population data. In a survey of students in a statistics course, the following information was found. 55 of the students owning dogs had one dog. 33 of the students owning dogs had two dogs. 9 had three dogs. And 3 had four or more. So we're asking, is there a significant difference in the number of dogs per owner in a student sample versus the nationwide statistic? Use the chi-square goodness of fit test using alpha level of 0.05. Okay, so in this first column, we're going to put what was given and what percentages were given. So one dog was 62%, two dogs 26%, three dogs was 7%, four or more dogs was 5%. Next to the percentages, I put the decimal of the percentages. All right, second step is the observed count. So you just take this column and you fill in the observed count. So, right, 55 had one dog, 33 had two dogs, 9 had three dogs, 3 had four or more dogs. You add these observed counts and you get the total, which in this case is 100. And next step is you want to get the expected count. Now, we get the expected count from the percentages from the population. So what you do is you take the expected count percentage in decimal form and multiply it by the total observed count. So 0.62 times 100 is 62, 0.26 times 100 is 26, 0.07 times 100 is 7, and 0.05 times 100 is 5. All right, now we have all the values we need to plug into the chi-square formula. All right, the chi-square formula says chi squared equals the sum of the observed minus expected squared over expected. So you go here and you take the observed, which is 55, minus the expected, minus is 62 squared divided by 62. And you do that for each of these categories. The categories of one dog, two dog, three dogs, or four dogs, four or more dogs. You take the sum and you get your chi-squared obtained value of 4.046. Then it asked if this is significant at 0.05. The next thing you want to get is the degrees of freedom. Well, there are four categories here: one dog, two dog, three dogs, four or more dogs. So degrees of freedom is n minus 1. So n number of categories minus 1 is 3. Next step is you want to get the critical value. So if you go to the chi-square table on page 711, you simply go to degrees of freedom of 3 at 0.05, and you will get a critical value of 7.81. Our obtained chi-square was 4.046. So we are going to fail to reject the null hypothesis here. In other words, the sample of students' dog ownership is not significantly different than the population dog ownership. Question 2. A genetics engineer was attempting to cross a tiger and a cheetah. She predicted a phenotypical outcome of the trait she was observing to be in the following ratio: 4 stripes only, 3 spots only, 9 both stripes and spots. When the cross was performed and she counted the individuals, she found 50 with stripes only, 41 with spots only, and 85 with both. According to the chi-square test, did she get the predicted outcome? Test at the 0.05 alpha level. All right, so similar to question 1, we're going to put what's given. 4 stripes, 3 spots, 9 stripes and spots. And we will put the observed numbers there, which are given: 50, 41, and 85. We'll take the total of the observed numbers, and we'll get 176. Next, we have to find expected. However, we don't have a population percentage for this. So we have to estimate that. And the way you do that is you take each categorical variable, divide it by the total number in this categorical variable, which is 16. 4 plus 3 plus 9 equals 16. And you multiply it by the total observed. So 4 divided by 16 times 176 equals 44. 3 divided by 16 times 176 equals 33. And 9 divided by 16 times 176 is 99. Now here, instead of just putting everything into the formula at once, there's a table you could use to make it simpler as step by step. So here, if you just take the observed minus expected, you'll get 6. You square that number, you'll get 36. And then you take that squared number and divide it by the expected, and you will get 0.82. So you'll do that for each variable, and at the end, this last column will give you your chi-squared. Now this is just the table way of solving the chi-square formula, as opposed to up here where we just plugged everything into the formula directly. Both work the same, both will give you the same outcome. So now we have a chi-square of 4.74. We have 3 categories, so the degrees of freedom will be 2. If you go to degrees of freedom 2 on page 711, at 0.05, you will get a critical value of 5.99. Well, our obtained value is 4.74. So, no, she did not get a significant amount of the striped spots and striped spots that she was looking for. So, we are going to fail to reject the null hypothesis. This is chi-squared.